Hi, this is Kumaran. In today's video, we will discuss about the 8085 simulator. A simulator means it's a software tool which will give you the output same as a microprocessor what it is doing. So we will write a program in assembly language that will be executed. We will get the desired output. Then we will get a confidence that we are writing a correct program. So for that purpose only we are going for the simulator. Moreover, for the education purpose as an individual, it is very difficult to purchase a kit for the practicing. That's why we are going for this. So let's move on to the simulator. Before going to the simulator, we will discuss a task or a program. Then we will execute that program in the simulator. So here the task is addition of two 8-bit numbers. We have to add two 8-bit numbers and carry also to be counted. So you know that 8-bit number means between 0 to IFF. Any two digit number you can take. For example, I am taking that two number. So it is 8A. Then CD. So you can take any number between 0 to FF. That is not mandatory to take 8A and CD. The moreover, the data are available on the memory. That's the assumption we are going before the program. Because as a programmer, you can have a choice. The data may be with the programmer or register or memory. So for the sake of simplicity, we assume that the data is already stored in the memory. So we have to read these two memory bytes and add the both and store the sum and carry on the corresponding memory locations. So that's the assumption we have before going into this program. So addition of two 8-bit numbers with carry means the numbers 80 and CD. Let's add this in binary, whether what kind of sum and carry we have. So 8 means you know that 1 that in the based on that 8421 form. Then A is 10 is 1010. So it's likewise you can have binary equivalent for hexadecimal. Then the C is 1100, which is 12. Then D is 1101, which is 13. So now add these two. 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 1 0. So 0 here, 1 carried, then 1 and 0 is 1, here 0, 1 and 0 is 1, 1 plus 1 is 1 0, 0 here, then 1 here. So in this the sum is 7 carry is 1. This flag is called carry here. This bit is called auxiliary carry. That's what in flag register, this is carry occurred from lower nibble to higher nibble is called auxiliary carry. The carry occurred on MSB is called carry flag here. So here the sum values 5, then it's 7. So what answer you should get after the program? So here it is 5 7, then here 0 1. So that's the result for the give and take. You can take any number and compute this. So this is not that you have to take only this number. Okay. So this is the task we have to get from the microprocessor. This is manually we computed, but we have to write a program to compute this. So how to implement this in program? You know that to read a memory and to write that result. So these things you can perform based on instruction called LDA STA. LDA means load accumulator from the memory address. So for example, we will get this data here LDA, the memory address 4200, which means that the data from the memory address 4200 will be copied to the accumulator. Okay. So this is the data 1 we copied. The data 2 also we have to copy through LDA. That's why we have to make a copy of this data to some other register. So I am loading this, I am moving the data to some other register, for example D register from A register. So I can take the second one. So LDA 4201. So this is now the D register, at this point D register having 8A, A register having CD. So 8A plus CD we are performing. Here that we can do both way, because A plus B or B plus A both are same in addition. There is no precedence. Before that, to count the carry is a single bit number, isn't it? It's a carry is a flag, it's a flip-flop. You cannot copy the flip-flop, you can check. So for that purpose, we have to take one of the register to initialize one of the register to count the carry. So initializing means load that register is 0. For example, E register I am taking for carry. So for that I have to load 0 in the register. So for that the immediate. So use move immediate 0 0. To count the carry we are initializing it. So now we have taken data 1 in D register, data 2 in A register. E register is initiated with 0 for counting the carry. So now we will perform the addition. So add one data in accumulator, that's a default. Then the another data in D register. So add space D. So which means that it will add the content of accumulator plus D register, then the result also stored in D register. The sum 57 will be available on A register. But now we have to check the carry. Suppose carry flag is 1, what we have to do? We have to load that ES01 because C is taken for the carry. Suppose carry is 0 means leave as it is and store the results. So now we will implement one of the instruction here, JNC. JNC means jump on no carry, skip. Skip here is a label. You can use any label you want, even your name also you can use here. So jump on no carry means it will skip. Suppose carry occurs, what we have to do? We have to load a 01 on the register. Either you can use move immediate E, 01 or you can increment that register also, because already 0 is there. So if you increment INR, then it becomes increment E, it becomes 01 here. So now the sum is on accumulator, carry is on E register, both we have to store. To store the data, we have an instruction called STA, store accumulator. So this also from accumulator only we have to store. That's why store the sum to the corresponding address 4202. So while typing the program in simulator, we have to use hex, but while typing in the kit, no need to mention that hex, because by default whatever we are typing all are hex only in microprocessor kit. But in simulator we have to mention H. So while typing simulator, we have to mention all are H here. Okay. The sum is stored. Now the carry is on E register. Take to A and again use that. So move A, E. So from E register copying to A, again have to store in the next memory address. So it is not mandatory store use next memory address. Whatever the convenience, you can store anywhere in the memory address between 0 to FFFF. The 0 to FFFF 4-digit address, because we have 16 date address lines in 85. Okay. So that's it. The task is over. Stop the program by writing halt. Then one more thing is, we have written label here. That label jump no carry means we have to skip one step. That step is we should not increment the E register, because no carry means the 0 is the carry. So for that we write the skip label here. So this is the program for addition of two 8-bit number. So a recap, we have two 8-bit numbers from memory address 4200 and 4201. We are adding both. We are getting carry and sum like in manual calculation. We are implementing the program to read a memory address through accumulator LDA, copy to some other register, again get the second number in accumulator, initialize C register to count the carry. We are adding both. We are checking the carry flag. If no carry means straight away store the result. Suppose carry occurs, increment the E from 0 to 1, then store the result. So that's the program for addition of 8-bit numbers with carry in 85 microprocessor. Let's go and implement the same on in simulator. We have a simulator 8085. The software I am giving the link in the description. You can download it and straightforward installation. Just the application file, you double click and install. So you will get the app like Microprocessor 85 Simulator Software Kit 1.0. So this is the software we are going to use. So double click, open that. We have the software page. In this we have a carry flags, then the internal registers, accumulator, BC, DE, HL, stack pointer, program counter. Then this side we have starting address of the program. By default it's 8000. If you want you can change. That doesn't matter. Then we have instructions all here. So this is the page we will type our program and execute the program. So the typing the program we have two way. One way is you can type directly. The other way is you can click the instruction by in this appearance. Here all the instructions are appeared. So whatever the instruction you need, you can click also. By that way also you can type. But you cannot copy paste from somewhere. Already you have program in a Word file that you can copy and paste this, so that will not work. That's good for some extent, because you can type the program, then you can be familiar on the programming how it is. So that's the good. So already we discussed a program. That program we will type here. So we are using that LDA. When you space bar, then automatically it will show that which memory address. For example, the same we will use 4200 H by default. Then enter, we will get the next one. So move. We taken that D, comma A. But here in the software they have designed that space. Instead of comma they are using space. But when you type the program in the microprocessor kit, you have to use that move D, comma A. That's the real instruction. But this software they have designed such a way, instead of comma they are using space. We'll get the next one, LDA 4201. But H also default is there. So now we have to initialize the register, move immediate E register to count the carry 00. Okay. Now we will add both. Add D register, which means that A plus D answer is in A. That's the meaning of the instruction. Now we will check the carry flag J and C. Any label you can give. The same thing, jump, no, zero, skip we will give. So suppose carry occurs, we have to increment IN or E register. Okay. Now we have to write the label also. Skip, use colon. Then now store the result, STA, the address 42 02H. STA here 4202. Okay. And then we have to copy the carry to accumulator, then store in next memory address. Move A comma E. So here no comma, only space. Okay. Then we'll use here also the drag an option here STA in section where it is will LHLD STA carry. Yeah, you click that STA, the address also you click 4203. Okay, like that also you can do this. So the next one is halt to type HLP. So the program is over. Now the label is here. That label you have to type in this. Okay. So now the program is typed. If you want, you can save the program also. This option is save the code. You save this. Any name you can give. Add CM story. So now this option is for step info, compile the code. Either you can go with step by step, or you can run all at a time. So if it is clicked means this check in the starting address of the program, the code is converted into hex code. So this all the code, all the instructions are stored here. So here you have to note down the opcode of the instruction. In 8000 LD opcode is 3A, then the address 00 district. So the next 8003, the next instruction move D comma A. Likewise, you can find the opcode from all the instructions. The opcode has been calculated. Now we have to give the input also. For that, so yeah, before compiling, we should do this. So I'm stopping the emulator. Give the input 4200. What input we have taken? So let's go and refer 8A and CD. So have that 8A, then CD. Then the next outputs we have to write 00. Then only the simulator will write the corresponding result. Okay, these are all inputs and outputs we have written. Now we will compile the code again. We will go one by one. The first will check the accumulator. It will load the data 8A to the accumulator. Check here, accumulator loaded that 8A. The next one is it should be copied to D register. So check the D register, copy it. But A also will have, because copy paste only, not cut and paste. So get the second data in accumulator. Now clear the E register. Clear the A register. For carry by default it will be 0, but anyhow previous program might have result some data, that's why we are clearing it. Now we have to add both the 5-7 sum here. Carry flag you check, carry flag is enabled, auxiliary carry also enabled. This is what we computed in the manual calculation. So now it should not skip, because carry flag is 1, so it will execute next. So it will go to the next, increment E register by 1. Now it has to store the result. Check the here, the 5-7 should be showed on 5204202. Then get the carry 01 to A, that to be stored in the memory address halt. So that's all about the simulator 8085. So this is a sample program also we executed. Likewise, you can execute all the programs in 85 microprocessor. The only change between the kit and this software, here between move D comma A means here D space A instead of comma. So that's it program. Thank you. If you want all the programs, you can comment. I can discuss all the programs in this. You can get the knowledge about it. Thank you.